for coming here. And I will talk about something between science and art. In this paper, lighting as both and lighting science and as art. Sorry, I'm a little bit inarticulate at the moment. Hopefully it will pass with time. Since the topic is a very huge one, we will only talk about new technological advances and state-of-the-art examples by smart materials. Because normally architectural materials are static and they have very limited configurable features. But smart materials have this can phase very many things. And we will talk about architectural lighting in three different types of lighting: for task lighting, general lighting, and decorative lighting, and links between some smart materials and these lighting types, and also the future of this lighting as science and art. And we need light to see, perceive our surroundings. If there wasn't, we use light in the perception of the environment, the regulating of daily rhythms of our body. And we need light to perform some tasks such as reading and writing, for comfort and for aesthetics. But the quality of light has many criteria when we talk about the science of things. The visual performance is usually the foremost objective, and the visual performance generally relates to a suitable amount of light for the visual activity, homogeneous distribution of lighting, light and levels, sufficient perception of surface textures and three-dimensional plastic shapes, lack of glare, perception of color. Other important criteria for lighting are safety and economics. And for this conference, one of the main criteria is many important things is energy. This is a US case for 2013, and while it may change very much between nations, the European Union case is very much similar to this one. Nearly 40% of the energy consumed is consumed in buildings, and while the part of lighting is not the highest, usually, for example, in residential buildings it's around 12%. In commercial buildings it is much, much higher, and the first speaker talked about the double skin facades. They have serious implications on lighting and heating, and as well as heating and cooling. Daylight, as we talked about, is a prominent factor in how a space is revealed and perceived by the users. And these are the classical forms of taking light into a building, classical architectural forms, and creates an elevation that allows for natural ventilation. It reduces noise, provides shades from the intense heat of the Indian sun, since this is a project in India, and is also designed for clients with limited resources, and creates a highly complex facade at a reasonable low cost. But on the other side of this is building integrated building management systems for solar control. They allow both heating and lighting control related to the position of the sun. This building was also designed for optimization and in its first form stage, and these Morash pentagons are open and close, integrated with the building management system. And this is also a similar system which includes layers that work in a clockwork-like mechanism. They allow for entrance of desired light or prevention of entrance of light. And when we come to the state-of-the-art the smart materials, smart glasses change their optimal properties according to stimuli such as temperature, light density, and electrical fields. They turn from transparent to opaque or colorful state and can be photochromic, thermochromic, or electrochromic glasses. This is the electrochromic glass, and it has 5 layers of tungsten oxide film of nearly 1 micron thickness. And according to the given voltage, between 1 to 5 volts, its optical density changes proportionally to the given current. And it was used in this building with a Siemens wind turbine assembly facility. The building uses the light. In fact, light was an important factor in its design. 75% of all the spaces use light from windows and skylights in this design. And it has also automated controlled glass facade with increases its daylighting potential. The 455 square meter wall has 30 zones, all of which are integrated into the system, and the glass is dynamic. It electronically tilts and tints and clears. Thus, it modulates light, heat gain, and glare inside the building. We can see it in another shape also. The light-emitting diodes are smart material that has become increasingly popular over the recent years and have begun to be used instead of traditional lighting fixtures. They can create white light and very closely to real sunlight. They are compact in size and easy to install, have greater efficiency, lower carbon footprint, longer life, lower maintenance, and low ultraviolet and infrared light creation. And its linkage into the architecture is given here in general lighting. General lighting, such as many areas, such as corridors, environments, and multi-purpose rooms, do not have very definite illumination levels. In this example, the Northwest House is combined boathouse and clubhouse in Austria, and it showcases back the richness of light that can be reached by the utilization of LEDs for multiple purposes. It is part of a rehabilitation project for around this lake, and the design and the lights draw people in, and the biomorphic concrete form allows light and shade to move inside the building. Both in the morning and in the evening, it is striking milling with a DMX control device that controls both the colors and the illumination level. Photoluminescence is luminescence of excited, given by excited atoms. It can be linked to decorative lighting in architecture, while since aesthetics is also an indispensable part of architecture, and decorative elements lighting photoluminescence can accentuate or give information about an object or create privacy in space, and are interesting design elements. This is a cool glow for glow in the dark ceramic tiles. We can charge these decorative elements in the morning, and they will illuminate around 8 hours in both the previous example and in this example. And in this example, the molecules become excited by LED lights, and in the previous example it was using the sunlight. And these are not, of course, the only smart materials or technologies there are. Fiber optics can allow us to take natural light into the spaces and make unlivable spaces livable. Even trees can regarding their potential, and there are many other studies about biomimicry. This is about how we can take how a plant that looks at the sun and build a building like that. These shades follow the sun by elastic deflection. And the smart materials and other new technologies give us very numerous new materials, and this is the science part, but they also need to be employed, and some are thankfully I think being employed at a wider range, but construction sector is not very open to the outside, and usually needs very many examples that show that the technology is good, it has no external effects on the environment or human health, and it also has to be economic, efficient, and aesthetic. So this paper try to give a framework by state-of-the-art examples, and thank you for listening to me.